Hello and welcome to another weekly live stream. Tonight we're kind of going to be continuing where we left off and trying to integrate, quote unquote, all the things. So yeah, let's go ahead and get started. Hopefully I've got this all set up correctly today. There's my superheroes. Oh yeah, I've got a light up here now, so I can turn it on and be a little less sitting in the dark. Yeah, so those are my patrons. If you'd like to become a patron, their links are down in the doobly-doo thing. Otherwise, let's go and get started. I've actually I've broken things compared to last week because I've been converting them over to real code, and I've done something at the last minute that messed everything up. So I'm real quickly going to try to undo all that. I was trying to. I'm not sure I'm going to like that light up there. It's kind of bothering me a little bit. If I can just turn it slightly. Yeah, I guess that's okay. Alright, so yeah, I added all this stuff to whenever you fork or clear an action, it delegates up to the parent, and I kind of feel like that is what's messing me up, but I won't know until I try. According to YouTube, nobody is on. One person, maybe. Alright. So what we're going to try to do today is, assuming I can get this activity stuff working again, is set it up so we can send the character signals ultimately things like hungry, all the things that we were sending signals to the old ones for, things entering their view and so on and so forth, triggers for those, but also to put them into nighttime sleepy mode or daytime working mode and have those sort of manager activities run. But anyway, in the meantime, I've got to get all the things that were working before working as good as they were. So I'm trying to get her to create a dagger. I switched over to real Java code for the brain and activities and stuff, and so I'm in the process of debugging why those aren't. Yeah, so see, let me cancel. Something is not working correctly. It's trying to run. It gets through here, create daggers null, and so it's supposed to run all of these things, but for some reason is forked is false, but we also haven't created a dagger. And so yeah, so we should have been what should we have done? We should have let me add some logging in here. Let's go ahead and let this run. I have trouble, again, while I'm on the live stream, I have trouble thinking straight, which is why I'm trying to get all this stuff done before. So, log info, forking, get hammer, forking get rod, forking walk to anvil. Okay, we should be able to. And the other thing is, there was some state issue too, where I was having, or if I just ran the test again, it was having a different error. So we'll see if we've gotten at least past that. Yep. Okay, good. That's an error I can deal with. I get used to having log everywhere, and because in the scripting environment outside of the classes there is already a log, and in all of my classes that I create I already automatically create a log as part of my class template. Okay, so just cancel just to make sure the brain is cleared out. Dagger. Okay, so now we've got, there's already forked action. See, this is the thing. How could there already be a forked action? Get hammer, get rod. We won't have a hammer or a rod, so we should have forked, and we should have been forked. I'm wondering if is forked is not pending working. Okay. Run. Pending working false. Pending working true. Did I screw this up? Is forked should tell us whether we have any forked stuff. So let's, thing is, like, I can't debug that because that is, I think it's a state problem. But anyway, is forked pending working. So you catch me mid debugging. I apologize. And let me check pending working to see if I'm setting it correctly. Yes, this is all managing the context. So the idea being, when we run, we see if anything has been forked. If we have a child that is run, yeah, so I'm not actually checking. No, because if they had run, if they were success, they'd return false. And is forked. And I actually want to know this. Yes, so for whatever reason is forked. Now I do actually have unit tests. I could actually test this probably. Let's try to find one that does multiple things. I think I don't have a test like the other ones. We could add one real quick. So what do I want to call this? Collect things, influence, activity. Thing 1. Thing 2. Collect things. So this is just a unit test kind of thing. So I could do automated testing without having to load up the whole thing. This thing 1, and thing 2. And then I'm gonna steal this stuff. Yeah, so I've tried to simplify the run lifecycle for a activity so that it's a little clearer what fork means and so on and so forth. But now I've apparently broken things. Get object get one. So if we want to I think I'm going to empty these out so that you can see what I'm talking about. So we have this thing we want, like I'm just arbitrarily, let's say this was the create dagger and I wanted to get a hammer and get the, I'm just trying to test the functionality. So in here you would create your individual get, you know, for the actual things you want to get. Oh, I got to pass containers. This is not a fully fleshed out world or anything, and so it needs a little more state from the test environment. Normally you wouldn't do that. You'd ask the agent for things like this, but you know, containers nearby or whatever. Containers the NPC can see. Okay, so the object to get thing one out of these sets of containers, or get object thing two out of those sets of containers. And then in here we ought to be able to say context fork get one, and then on failure we want to set failure. Action result failed. I need to change that, but and then we should be able to go straight to 2, but because I'm trying to test something specific, let's, if context is forked, return, and then that should be all that needs, and then we have to make a test. So I'm going to put a second let's just steal this test, and we'll come down here, we'll say test coordinated activity. We don't want that, we want 2 of these. Oh, 1 and 2, 42 and 43, and we'll put them both in the last container. And actually, yeah. And then we want to collect things, object 1, object 2, and container locations. We want to run that activity. We want to run it at least 100 times and see what actions come out. Okay, so we run the test, activity test, test coordinated activity, boink, 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 boink. Let's see what happens. Oh, yeah. I've neglected to construct the object. Yeah, today I spent like messing with pathfinding because I'm trying to get that one finalized as well. I started trying to move the activities over, and I realized I needed to get pathfinding moved over first before that would really work. Okay. In test agent, line 102. That's, oh no, it's in activity kernel 339. Sorry. Last results. This is a forked action. Yeah, so it shouldn't have been trying to run this without having run it, update at least once. So something is not right. Yeah, we tried to run actions twice, apparently, is what I'm guessing. Alright, so now I gotta sort through all this. Run action move. Run actions forked move action. Forked action finish. Why are we finishing? Did we already arrive there? Let me verify. Now this is something I'll want to remove before running it in the real thing. Let's run it again. But this is a way more rapid way to deal with issues if you can set the tests up right. Alright, so yeah, we run it and then we fork it immediately. Or we finish it immediately without ever having run it. And that's not right. And why is that happening? Okay. Yeah, something's finishing. Alright. So we update the activities. We're going to look in these 3 containers. Where does 112 come from? That's not supposed to be 112. The tests are labeled, the containers are supposed to be labeled in a specific way, yeah, so I've accidentally left a 2 in. Yeah, that's fine. Okay, so we created a context, a child context. Turn to calculate the path. I'm going to add some more debugging for context here. Let's see. I'm going to say run action is logged already. Fork we're going to log as well. Okay. Okay. So it forks get object twice, right in a row. Yeah, because it's not labeling itself, so I need to know which get object it is. So down here where we made get object, we're going to add it to string. Get object at system identity hash code this object to get. Okay. I think walk already. Nope. Well, there is only gonna be. We're not going to be able to distinguish the walk anyway, because they'll look the same. There's going to be 2 different walks, and they're going to look the same, other than their identity hash code, which will already have different. Okay, so we're going to fork this one, and then we're going to fork this one. So already we're busted. We don't have to look very far. Is forked pending working false. Yeah, so see, we haven't run the things yet. Because we run them at the end. What I wanted it to be was that when you run these things, it was like when you call context fork, it runs it right then. Right from here, it just nests it, that call. Same with this context fork. So basically, it would just run these inline, and you could reason about what was happening. The problem is, like, I can't do that and have these on failure and on success hooks, because when you call the method, it returns something, and then you set the on failure. The method's already run. I can't then go back and do the thing. So I had to do the thing already, and then it's too late for me. I won't know what you set on failure. I probably could have made it work with some weird back and forth state stuff, but as it stands, what I have set up is that when you call context fork, whatever context fork happened within this run will run immediately after this run method is done. But that means this context is forked is a little messed up. It doesn't know that so it's basically, this is what's broken. This is forked call. It doesn't know that we forked something because the code is messed up. And so when we fork something, we add the forked context, and because we added that, we need to assume that it's going to make that true. I was trying to get clever, and here's where it runs our activity, and then afterwards where it runs all of the children, and sets the pending working true. Basically, if all the children succeed, then we're not still forked. But and we could exit out at that point. I don't know if that's right either, because what if run had more stuff to do? Yeah, I don't think that's right. I think I was trying to do what I just did before, which is essentially if you run the activity, run, and it doesn't fork anything, and it leaves its and it sets a result to success, then you shouldn't run this activity anymore. It's done, right? I think that's what I was trying to capture, but I wanted to make sure that if you had forked something in a previous run, that it got cleared out, and it only counted what happened in this particular run. And I just think I did it wrong. I don't think I need to keep track of each one that ran unless I want to remove them. But I'm essentially already going to be clearing them. I kept the last ones around in case we want to check and see what ones were removed. And so I'm doing this, but I don't think I need to. I think it's redundant because nothing's going to get a chance to check that. Run method's already done. Well, I guess. Yeah, like I said, if we finish. Oh, it's an or, right? Yeah. So in order to, when this run returns false, that we stop the activity, we don't continue it. And so it's an or, right? So if I'm still working, or I'm forked, then we continue to go. So I think this is okay. I think I can leave this in even though it's not doing anything. All right, so now that should have fixed our problem. Yep, and so we moved to this. We took one, we didn't take the other. Yeah, no, see, something is messed up. This is why. We don't run it, and so we don't know if we're forked or not. So I might have to implement the more complicated way where we run them inline. I only just figured out how to do that, so like it only just occurred to me. What we return, so yeah, this is not really what I meant to work on today, but I mean perhaps it's interesting anyway, and we'll get closer to the model that I really wanted, so that's all right too. So like I said, when you call context fork and you pass in this other activity, the idea being I wanted that activity to run right then, and then whatever that result was, I could on success or on failure chain that to myself, you know, do this, pass the failure on, or do some other activity. But I wasn't able to do that because of the whole, you know, on failure set after we run kind of thing, if we ran. But so what handles that is this forked activity down here, or forked context. Yeah, so and then we run that, but I think that I can just run it inline and then have this on failure, instead of holding it until we're done, just keep track of the status we just got and just run it. And so I think because we're on the live stream and I frequently do really dumb stuff on the live stream, I'm going to keep this old version, like, so that I don't drive myself crazy, and so I don't have to look at git diffs just to figure out what I'm doing. And so if we so the thing I couldn't do in that case is default behavior. Right here I've set up default behavior, which could have been automatically forwarding success to the parent, you know, to the real context, or automatically forwarding failure to the context. And what I'm proposing doing is running during the fork call, and at that time I won't have these set, but if they're set I could go ahead and run them. But if they weren't set, I would have to have some other point to clean up. Well, that's borrowing trouble from tomorrow, because I haven't implemented that yet, and so I won't need this. What I will need is action result, last result. I'm going to go ahead and clear these out. And so forked context, this will run the context, and if we're still busy, we do that. Otherwise, what we'll do is we'll capture the last result equals context get status. What I'm seeing here in the output is that we didn't run both take objects, and what that means is that while we fixed is forked to return true here, it always returns true because we forked this, but it didn't run yet, and so we don't know that it's going to already say, yeah, I'm done. Right? And And so the second time through, we don't actually ever get here because it always looks forked, because we always forked this first one even though we already got the first object. Get1 knows that. It's going to tell us, but we don't know that at this point. Whereas if I ran it in line, we would know. So I don't need this. I can return false. And then in here, I would say if last result equals action result failed, failure callback run. And still return this because, and then this one success. Success callback run. And still return this. Now that should have fixed the problem. No, I gotta actually run it inline. So instead of here, instead of just adding it to pending, we say if fork run pending working true. And then we'll return the fork, and they will add their things, which will run them, or based on what this said. And so then we never add anything to pending anymore. I'm gonna just double check that that's true. Yep, we never add anything to pending, so we ought to be able to get rid of pending and last pending. Pending working we should have. Don't need this, but yes, so we'll set pending working false. We don't need any of this stuff. And so this will fork things. If those things are still working, we'll get pending working true because of this right here. Alright, let's try it. So we should see 2 moves and 2 takes. Yes, we did. First we took 42, then we took 43. So that's the way the logic should work, right? In this run method, we're saying, first get the first object, and if that fails for whatever reason, then fail the whole activity. And if that's still working, just return. Otherwise, try to get the second object. If that's, and then regardless of whether that's working or not, we're done. Though we could also just default to yeah, I don't know how it ever gets set to success. How do we finish? Oh, I bet we ran over and over and over and over and over again. Yeah, we ran all 100 times. So that was the problem too. We never actually finished. This is going to be a problem. And that's why I've considered having it be default this, but then wiring all these together. Anyway, let's see if this makes it run fewer times. Okay, now we fail. What? Say what? What have I done wrong? Action result failed. Success. Find result. No, that's just telling me a suggestion. First of all, I want to... Yeah, so we never saw the done in. It never actually finished. It's interesting. We still had actions. Oh yeah, the action log. Yeah. We ran the actions. Okay. So what is actually failing? No context set result. Set status. That's funny because because these never failed, we don't have tests to test for failing, and that I never caught the fact that I had been using the wrong method this whole time. It's called set status, not set result. So how many iterations will it take? Say, that's fine. So done in 13 steps. Yeah, because I had to run the actions. And the actions are coded to take a couple frames so that they simulate real things. Yeah, even the walk. All right, so it did all the things. Managed state correctly. We should be good to try it in the real thing now. So YouTube says I have lots of views, but not many concurrent viewers. Story of my life. Finding bugs and things that I hadn't intended to work on today. Yeah, I wonder if my chair is... Yeah, I need to replace my office chair. It's the little adjuster thing slowly leaks and lowers me down. Alright, so brain, go make a dagger. Follow you. Follow. Yeah, we got so much output now, I'm going to have to clamp those logs down. Yeah, I meant to remove that one log. Yeah, I'm trying to turn these into lines instead of lots of individual little things, and then I got down the rabbit hole of fixing the collision shape stuff. I've got a couple hard-coded values that only work with her. Uh-oh. Yeah, she's stuck. Get object, get object, get object, get object, get object, get object. Okay, so cancel. This may be a problem in our actual code. It's possible that it is not paying attention to the new model. So this is good. This is good. Yeah, because that's the other thing. If you reuse... Yeah, where does she end up? She ended up here. Yeah, so if you reuse a action, like we do, in get object, it's going to... either of these get objects. They're going to keep going, and if they don't find it in one, they're supposed to, go to the next. But there's a new way to restart an object now, or restart an activity that has not been ported to them yet. So I need to look and see when I did it. Yeah, so if we didn't find a... Okay, so yeah, it keeps track of whether it needs a restart or not. We'll have to port that behavior. Okay, valid. So some of the base actions like this will take a little care because they want to be reusable in a certain way. Valid. So anytime we do that. Anytime we remove, nope, if we actually removed it, invalid, true, return false, return true. So let's do a boolean. So since we walk to the nearest object, but we've already got our path set up and everything, we've already calculated path, so we already got our path and everything set up in the objects, and so we just remove one and we rerun it. You know, potentially it could have cached information. It doesn't, but it could have. And so because of that, we have to have a way of detecting that we need to restart it and then restart it. And so I think there's already a thing that's removing the target. Let's look for remove target. Yeah. Oh no, it's not. Ah, yes. So now, used to be the action was already set up. The walk to nearest object action was already set up so that when it arrived at the first action, it automatically reset itself. But then you couldn't look and see where you ended up. If you wanted to, you couldn't, because it already cleared that information out. And so now you have to specifically say, you know, and anyway, if you were already standing next to the container that you wanted to get something out, you would still try to navigate to it, even though we're about to go through this before we even fork that action. And so the idea being here, if you found that container at all, like you're standing next to that container, you don't need to navigate to it. So regardless of whether you found something in there or not, in fact, I'm going to steal that code from here. Yeah, so this is like, yeah, I was able to simplify this quite a bit. Yeah, so if we're in range, we can go ahead and remove it, because we'll never need to go there again. Yeah, so before we do anything, we called it walk and remove target, takes the entity ID, and that's what this is going to do. Alright, if we satisfy the requirements, then we're done. Let me check the logic over here again, because it's way better over here. Yeah, so I did it with an action there, which is why I have this here. Otherwise, we just do this, and we fork. Yeah, this one doesn't actually have the, oh, because I know why, yeah. Okay, we're going to need something similar for the other get activity. So if we do that, I'm going to steal this other code too. I'd like to combine these two somehow, but they're different enough. This is the only loop that's the same between them. Yeah, so regardless of whether we found what we're looking for in there, we definitely don't need to walk here anymore. And none of this is going to fork an action or anything. Really, it should. Right now it does the direct, pulls it out of the chest and puts it on the player, but it really should be running an action so that if we wanted to have the NPC reach into the, open and reach into the chest, we could animate that. But it doesn't do that yet. Okay. So if it needs restart, we restart and we walk. Yeah. Nothing is checking to see if we've already got What we need, though, are we keeping track of that? No. We could, though. Found equals false. If contains that's actually the check we want. We don't necessarily want to know if this get object. So like you want to be careful how you construct your conditions. Like, so if I had done it this way and I said, okay, when we get the object out of the chest, we'll set found to true, right? That would technically work, right? This get object would say, yes, I already got the object. I already ran, this activity already ran, and I got the object out of the chest. But what that doesn't do is it doesn't catch the case where maybe the NPC wants to get that object, but in the meantime, you know, the player reverse pickpocketed them and put the object in their inventory. So they've already got it. They'll never get it. And so they would never find it, right? So that's not the test we want. We want this test. We want to see, does the thing already have the thing? And so if it does, and I think, yeah, we set success here and we return. So technically, we're okay. But really, you would want to have, even if you didn't find it in all these things, you want to have it. Oh, we have it at the top. Never mind. Yeah, so when we run, we already have it. So we'll have exited out long before then. And then the similar with the get by type. We want to make sure that, yep, so if we've got, yeah, so this one is actually, yep. And it keeps track of what we found too. So I think we're good. I think this will work. We'll see though. I've been wrong a bajillion times before. All right, see if it works. Oh boy. Stop, cancel. Walk to object, start working. Walk to the nearest object. So that was in the say stuff. Something is unhappy. So some in this, am I getting any hammer or am I getting, I want to debug the right one. Create dagger. Let me make sure create dagger is doing what it's supposed to. I didn't even think about that. Create dagger, we find the, okay, so this will tell us what it's going to run. It's going to walk to nearest, those are, okay, get by type. So it is running two get by types. We run the get hammer. Do we see fork and get hammer? We see lots of stuff. Create dagger. Fork and get hammer. Get one hammer. Looking in chests. Nope. And so then it wants to walk to somewhere. So it starts the pathfinder, iterate, yeah, see, that's the thing, is we're going to be checking each time we iterate the pathfinding. So I think it's actually potentially working. It's just doing a lot of work that it shouldn't have to do because of the new model. And that could be pointing to a problem with my design. Yeah, so it's still iterating, right? Even here, iterate. So, and what was the say that it was doing over and over and over and over and over again? Yeah. Walk to first object, start working. Start. Oh, yeah. We shouldn't be starting over and over again, though. That's wrong. That's wrong. Oh. Is anybody calling reset? They should not be. Nope. Nothing sets invalid to false again. As soon as we run through as soon as we start, invalid equals false. Let's try that. Brain. Dagger. Brink. Hey! Yay! That's better. Okay, you're gonna get the hammer and the hammer and the rod. You're gonna make a dagger. Clang, clang. All right. Woo! It's like we spent an hour just fixing my bugs. Well, that's awesome. But we had like a interesting time doing it. So yeah. So they finished. They made a dagger. Look, they put the dagger in the chest when they were done. All right. Wow. Okay. Good times. Good times. Yeah. So I need to, turn these into real things and clean them up a bit. Yeah. Fortunately, it's already doing the quick checks first. Yeah, 'cause that's the other thing. As soon as we check a container, we can also remove it from here. Right, neither here nor there. And get by type and get object should both. Well, I mean, we actually verified. I think that they both work. All right. Okay. So now the idea being, I want her. Wow. Yeah. So. I need to fix that one. We're gonna need to do a little Java coding anyway, I think. But I'm gonna go back to. I changed this before, and I think I'm gonna have to let it go back to just being default. So like when you have a sequence, it's dumping the whole list of. That's why we get these really long. Log messages like this, where it's because until we have like an actual walk path, which is what I was working on earlier today, where I was going to have like individual step actions, and it's going to be long. So in the old Mythruna, in the old brain, we used to have like signals and signal handlers. Let me see if I can bring up the old. That would have been under Sim AI. Yes, I'm structuring the new stuff so that maybe I can pull it out into its own library, and that's why I'm leaving the open source headers in, because I'll open source that stuff. But the old brain had like triggers and signal handlers, and so triggers would run every frame, or generators, signal generators and then you had like these signal handlers. I'm thinking we can just maybe port this stuff over directly. And so like when a player walked up to the dog, for example, and clicked pet, you know, that would send a pet signal. When you talk to the NPC, it sends a talk signal. When you came running up at the Gafen, you know, they got a moving object signal that was generated from like a standing query they had for anything that entered their field of view. These kind of things were signal generators and signal handlers. And I think that idea still works, so that when the town wants to tell the NPC, you know, it's time to go home, you know, it can send a signal, say work's done, and let it do whatever it's set up to trigger when work's done. So the town itself that's managing like everybody's daily schedules can just send signals, and then it's up to the individual NPC configuration to do something with that signal by registering a signal handler. So let me re-look at this stuff real quick. If we can just pull it over, that might save us a lot of time. Oh, it's even still got open source headers in it too. In 2024. And I may want to clean up these interfaces because Java's come a little bit since I worked on these the first time. Yeah, so we had filtered, yeah, based on the type of the class, but signals, yeah, so all this generate reaction stuff is not needed anymore. So that's bogus. Let's see what a signal handler looked like. I think the signal handler had this stuff, and we don't want that anymore. So that's a part we won't be able to copy. Yeah, because we don't have that reaction stuff anymore. Reaction was kind of a weird thing. It's kind of just a wrapper for a behavior. I originally had an idea for like trying to make some generic reactions that would then have pluggable I don't even remember actually, to be honest, which is one of the reasons why we're not using it anymore. It clearly made sense to me at the time. Yeah, so that part's still true. Like, what do we do if we don't want to deal with it? But I kind of think that maybe we don't want to do this at all. So when we get a signal, like what we have now is the brain, we have the agent, and on the brain we can run actions and activities, or get the agent if we want to do something with the agent. And kind of what we want to do, I think, right now there can only be one activity at a time. But I think what's really going to happen is it's going to be kind of like a prioritized queue of activities. So you would have your sleepy time activity, which would constantly make you want to go back to bed, right? So if you're not already in bed, it's going to perform the actions to put you in bed. And so then, but then you might get interrupted with something else. And so that activity would still be there at a lower priority, but something else would trump it. Do you ever watch your old streams to figure out why something made sense back then? I have, actually. I went back. There was this stream where we were messing with something in Lemur to do like configurable text component creation, and I had left that as a to-do to go back and finish, but I could not remember what we hadn't done and where I left it. And So I went back and watched that stream all the way to the end to figure out where I left things, because like my memory said at the end of the stream that I was like, oh, we could have done this a totally simpler way. You know, and in the last 5 minutes I was like, oh, well, we don't have time to do that. I'll do that on my own, and then, you know, get that thing fixed. You're like, this was already using strings. Why did I do all this other wiring? And so I had put that off for a long time, but I went back and watched the stream, and then I went back into the code, and it turned out I had already finished it, and it does work, and so the stream was not entirely helpful. I apparently had moved on, and then just didn't have any mental record of that. But yeah, no, I have, and it's potentially that I could go back. AI in particular is one of those things where I think about it all the time, and my brain comes up with new ways to do the things and quickly buries the old ways. And so even if I did understand what I was thinking, that doesn't mean that it's going to be better. And like, I have notes files. I can actually go back and read the notes, but they're going to be way more detailed than, so this is my one on the current 2026 Mob AI new architecture, which were my notes on trying to figure out sort of re-pulling all of the things together, figuring out what we want, all the current behaviors do, right? So I want to be able to replicate all the current behaviors, and so I was trying to reconcile all the current stuff with my new ideas, and so I can, for any given time period, I can go back and read exactly what I was thinking and have mental arguments with myself. It's like, no, that was dumb. What were you thinking? That kind of thing. Or, oh yeah, I forgot about that. Yeah, so this is still talking about strategies, and we've moved on from there already. So here we got started coding and prototyping. You have the super basic brain strategizer stuff. That was on February 12th. And this has been a frustrating couple months, because every week I seem to disprove anything that I thought of previously. And so trying to figure out where I came up with the new idea. Yeah. And I have a ton of these. Like, this whole folder is filled with files all the way back, so, before they were even dated. I have old stuff, getting the original Mythruna working from 2021. This is the new Mythruna. I have text files for the original Mythruna too. World coordinate systems, all these kinds of things. So I go back and like reboot my brain for that particular topic. I'm trying to figure out exactly the point where, so see here, I had relearned behaviors and signal handlers, and at some point I go through and I'm like, no, none of that will work. I have to do, so here we're starting to get into the idea of forking sub-activity. So I hadn't figured out what I wanted to call these. Oh yeah, I did. Parent activity versus child activity. So already we're at this point, we've worked on to do activities now, and this is the one that's stuck so far. But yeah, there's lots of stuff. I mean, potentially it's a little embarrassing. I don't write these for anybody but me, but potentially there's probably some value as a curiosity to publish these someday and let people read what my brain was thinking of. The question is, how much do I edit them? Because, like, I don't know how much of it's embarrassing, just me jibber-jabbering with myself. A little bit schizophrenic, but I do find it useful to go back and read what I want to get back up on a subject. And frankly, it's the only way I would have been able to survive, because I sometimes don't touch a piece of code for a year or more, and I can go back and read what I did to originally design it, get back in the sort of the headspace. Anyway, so in this case, probably something will tell the brain, hey, here's a signal. Yeah, well, in fact, let's see what signal looked like. Maybe I can keep that. So a signal, yeah, I had the idea of a heartbeat, but the signal would probably want, yeah, so it can take a value. So a type and a value. But then why not make it just a class on its own? Like take any class you want. Right, so instead of having a signal where you pass an idle string in, just have its own class that's the idle signal. Don't know why we need to do this. And so like for talk, and I don't think did I create subclasses anyway? No. But let's look at the talk behavior. What did this do? Yeah, so a talk signal handler would have gotten like signal talk with the value being the thing doing the talking, right? So the player. And then this talk behavior would get created as part of the signal handler. And it basically just makes the converser face the... So in the new way, this would be an activity. I would create a, pay attention to talker activity that would have conditions where it would keep the NPC facing the player, or whoever talked to them, either for a certain amount of time or until the conversation was ended, that kind of thing. So we wouldn't have a behavior, we just have an activity that would get pushed on to the stack, potentially interrupting what's already happening. Or maybe not. If what's happening already is a higher priority, it wouldn't. And so, yeah, this is on start, on stop. Yeah, set steering primitives. So yes, we'd want to be able to set steering primitives or run actions. Probably run actions. Because we can fork an action, get notified when we're done. I'm just trying to decide if I want to keep this idea of a signal that's based on a type string and an object. I definitely want something parameterized, but I'm just not sure why I couldn't have had individual classes. Let me see what ways I used signal. So we had a signal queue. Yes, so multiple signals could come in, we could work them down. That's probably still a good idea. Yeah, so yeah, so here's the thing, right? If we look at brain configurations, like I even created okay, so this is you could watch for a very specific. This is like how you set up the signal listeners. So on signal talk, yeah, so we'd get the brain and the signal, and this would be where we would set up the activity instead of a reaction. See, this just seemed like an unnecessary indirection. Why couldn't I have just returned the behavior? Right. Because something's taking that reaction. Oh, that's not going to be it. That's not what I want. I want to look in the brain. Figure out what we're doing with the... So we generate a reaction. Current behavior generated an action for this signal. So yeah, that's right. All of the behaviors themselves could be signal handlers. So like when a behavior was running, it was like acting like the brain in the sense that it would receive all the signals directly if it wanted them. And I still don't know why it couldn't have just returned a behavior though. But that's what we check first. If the current behavior had given us a reaction, then we do it. But again, like I don't know why we had to do the indirection. So let's keep looking. So it's got a reaction. For actions null, we set the reaction. And if we're idle, we generate a reaction for idle. See, that could have just been a base activity that's always there at the absolute lowest priority possible. So what does set reaction do? It's right up here. If we have an existing behavior, or if we get a behavior, I see. So here we go. We go through all the current signals from the signal queue. We generate a reaction. If we didn't get a reaction, we keep going. If we did get a reaction and it had a behavior, then we set the current behavior. See, I don't know why we couldn't have just gotten a behavior here. If we got a behavior, set the behavior. Yeah, so the reaction in direction makes no sense to me. But let's see how else we're using signal. Yeah, so here we have a signal generator that's got entered view. Yeah, that deals with perception sets. All of these things we'll have to get to as well. But yeah, so entered view this body, exit view this body. It's just here's my dilemma. I am not above getting caught up in patterns that don't necessarily have to be that way. And here's an example, and I'll pull up a new note file. Actually, maybe we'll do this in, yeah, this machine decided to reboot itself. And so I don't have my things up. I don't know if you guys can read this text okay. I assume maybe you can, but let me try to pull it up into something bigger. So this is going to make me like, yeah. Just running it is going to make me recover all these documents. Okay. All right. Yeah, so leave that as the last thing. Okay. So we have this idea that there's, oops. All right. Hopefully this is a little easier to read on the stream. Actually, I could zoom in a little bit too. So let me view, zoom. 150 seems awfully large and didn't actually do anything. Okay, that's hilarious. All right. Maybe it was already, yeah, so that's what it was. It was already at 150%. Yeah, okay. All right, I just hope that's readable. And so let me pull the signal class over and we'll abbreviate it a little bit. So the question is, do you have a class like this? It is readable. Cool. Okay, cool. So do you have a genericized class like this that you can use like this, where you have to pass the the thing, you have to pass a string, and the object, which technically I don't think I should have had to cast the body. Or do you have sort of a base class such that you could have so anyway, I'll continue down this thing. So where you could have like a exited view signal, implement some signal blah blah blah, and in here then it automatically knows this is a rigid body and so on, rigid boy. Because then when you used it, you would just say new exited view and then body, right? It would already have all the typing information built in. And I don't think, the only thing is you end up with this sort of proliferation of these classes that do almost nothing except for hold data. And so my tendency is to, at least for sure back then, right, was to just make a single class that took a type argument and work things out that way. And there's a little bit of a benefit to that too, because we don't just have this is not the only type of rigid body. There's entered view, there's talk, which in our case talk I guess would be an entity ID, and so then entity ID, talker ID, right? So you get all these different. So do you create 3 different classes in this case, or you just reuse the signal? And sort of the dilemma. And a lot of this actually could be like, if this syntax is what's bothering me, I could put a factory method on the signal class. I'm going to add another page so I don't accidentally keep flipping back to that page, and I'm going to put a bunch of returns here. There we go. Instead of this, I could have a factory that dot create entered view and then body, that then it could pick up the type from here, so that the method would be basically defined like static t signal t create string type t value, right? And so then I could do this kind of creation, and it would save me a lot of this generic rigmarole. I mean, one problem here is that I already had to cast, which means that it didn't really know what the type was. But also the thing is, like, the type, it's kind of irrelevant. Only the compiler cares. And like, if we were down in the Groovy wouldn't even care. And so a lot of times if I was coding this in Groovy script, I wouldn't even have to put all this crap anyway. So anyway, that's the design consideration, and now I remember why I did it, right? It's because there's going to be a ton of these different kinds of signals, and many of them are going to share the same kind of type, but then it doesn't make sense if you're going to pass a string. Why have to, like, so I could have done like a rigid body signal, which would have been the base class for all signals that take a rigid body, and then that would have been pre-typed. I wouldn't have to do this, but then I got to still pass a string. If I'm going to pass a string anyway, why not just do it like this? So yes, I think we will keep signal like it is. And the long story short, but that's the design reason we're going to do it. And so I think this is okay. I do think I'm going to create in the new version a let's go start making the new version. Yeah, see, I got rid of all the strategizer stuff. So signal. So we'll use the new header Mythruna brain. We got the big brains. We're going to want all of these things too. And we'll give it a Java doc for this time. Indicates some event that the brain may want to pay attention to. Okay. Signal T. I think we'll keep that. Oops. Keep that for now. The other thing I've discovered in initial development, I spend a lot of time working around generic stuff as soon as I start typing things like this, and I'm starting to lean towards the fact that when I'm still in the prototype stage, I should probably not be doing that and just use object if I don't know. Because a lot of times I spend, some percentage of every hour that I'm working. Actually, I could just steal this code. Some percentage of every hour I'm working debugging the generics stuff, because it's not all straightforward. And then I could have, and then end up deleting the class, right? Not even using it. I don't think I'm gonna put signal idle on. We will create a factory method though. Public static T signal T create. I think this is how it goes. String type T value. Return new signal T type value. I think that works. We can check it. Java will tell us. Yep, it had no problem. And while we're at it, we can make a... Yeah, what would be the... What did I do for idle that didn't take an object? Oops. I just did object. Yeah, okay, that's fine. So then we could have a signal object that just takes a string. All right. Okay, so it's okay with that. All right, so we have a new signal. What did the old brain do? I think we just said signal. Yeah, we're definitely going to want to have properties and whatnot. So signal, yeah, signal. Now see, this is really strange. Yeah, so I had a way of bypassing creation of the signal object at all, which indicates to me that having typed signal objects is not maybe not the best idea. and that's often sometimes, so this is what I was talking about, the dilemma of, do you start doing this? And it turns out I create a lot of problems for myself and end up never caring about the specific type of the value, because it's always going to be passed on to something else that will know better and isn't easily mapped to a so yeah, I think I probably did this to make it easier for scripting. That's not necessarily a good reason to do so. But let me sort of continue the thought where I was going with that. And I'm going to go and get rid of this strategizer stuff. It was so promising when I first started it, and then rapidly fell apart. It's almost a shame. It lasted almost 2 weeks. So you have this signal, right? You can put the signal in and blah blah blah. Then you have this method, which takes a string and objects, and because there is only one signal class, 99.9% of the time, this is going to be way simpler. So instead of over here, so you had options, right? We could have called brain dot signal. We could have done the old way, which was this big honkin', right, thing. We could have done signal. Now we could do the new way, right, like this, or we could just call entered view body and be done with it, right? The caller never had to worry about a specific signal class. I like this idea. And so the only brain interface would be this one, and then we would never need to have all that generic BS, because it's going to be up to whatever signal handler to decide what that value means to it. And it could be just logging the value or getting its name. It could be in Groovy, in which case it doesn't care what the type is. It's going to be able to use duck typing. So in that case, let's strip the genericized. Well, okay, that's the other thing is old brain had was ever, so it takes var args. What is it doing with those? So sometimes it's grabbing the first one. Yeah, so maybe we want more than one. Okay, so let me dissect this for a second. If the signal is talking, we strip off the first argument. That's the thing we're conversing with. If the signal was done talking, we may have had an extra thing, which was what we should say when we're done talking. So the signal may want a whole list of things in its payload. And I was working around it here. Mostly it's one. Sometimes it might be a second one. I'm trying to think. When we're done talking, how would that normally work? Because probably... So this was when you're in a dialogue with an NPC and you're going blah, 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 blah. And the conversation ends and you want the NPC to say out loud, not, not as part of the dialogue, but to just say out loud, bye, Mythruna girl, or whatever. But would that be something they would do when that activity ended? Right, we get the signal that we're talking to converser. So the signal handler for that would see if we're already in a talking activity, maybe. And if we are, add another converser to that talking activity, or do something else, or whatever. And then if this particular thing is done talking, we end that activity. And ending the activity itself could say something, but the act of ending the conversation may be deep in the like you may be deep in a dialogue tree, and so the activity ending might not have like the context to know what to say, whereas it was really easy when you called the signal to pass that information along. So bottom line, what I'm saying is that if we're going to get rid of the generics, these should be a list or an array, right? So that means we don't need this constructor. And we say this values equals values. We don't need these anymore. We got rid of those. So we can still have a convenience method to get the first value. Values equals null, null, values is 0. If values equals null or values.length equals 0, return null. Otherwise, return values of 0. And then object get value int index return value sub 0. If you're asking for a specific one, we could have a default. Anyway, I don't know how I'm going to use it yet, and so I think there's an arrays equals. Arrays deep equals or deep equals, yep. Not arrays, deep equals values, other values. Okay. And then the hash code values. Objects hash is, I think we have to do deep hash code. Don't think it will do that automatically. Elemento P. Yeah. Okay, deep return true if your objects deep equals. Two null values are deeply good. Both arguments are arrays. The error of them arrays deep equals. Oh, it's not what I want, but it could actually have worked. Oh, so I could have just I could have, instead of this, just done deep equals, and I left that other class out of it. Values, other values, and as far as the hash code goes, I think we need to nest hash values. Blah blah blah. The hash all the input values replaced into an array, and that array hash with the hash code. So if we want to see what it does with children, we have to look at this. If the array contains other array elements, the hash code is based on their identities rather than their contents. Yes. So then we want to do this. No. I think here we do want to say. Alright, let me just make sure that compiles before we continue. Oh boy. Yep. I don't think more objects lets me omit. I can omit null values, but I don't think I can omit empty values. So what do I have? Omit to string helper. I can omit null values, but I can't omit empty values. And so what I think I want to do is these signals are going to be in a lot of log messages, and so it behooves me, to do a little bit of better bookkeeping. So if values not equal to null and values length greater than 0, results dot add values arrays as list values, turn result to string. Alright, so now we have a nice toString method and we'll have saved ourselves a lot of time down the road. Alright, all that work. And now we don't need this method, except for internally maybe we want it, because we're going to have a queue that we're going to add those to. And then this one, convenience method, right? This is what everyone will call, because it's way easier than instantiating objects and whatnot. And so this one's just going to call signal, new signal, signal args. Doink, 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 doink. Yay. Okay. So technically we could have taken this out and put it up here and just done this. And let's find the signals queue. What was signal queue? It's in the brain. And the brain is further along in the chain. Haha. Signals is a signal queue. Why do I have a special queue for signals? It's a linked list and keeps track of the fact that they're unique. That's why, because I just don't want to add them if they're already in there. Yeah, so then it prevents, basically it collapses spammed repeating signals, which I suppose is still a good thing. So we will keep the signal queue. It's weird when I open something bright on this screen. I get it like, probably it's changing the lighting over here. So as I close this window, it's probably going to change. Yeah, so my face gets darker. That's funny. Okay, so we want to package Mythruna.brain. I think I put a space after. Is that my, yeah, that's my general template. Okay, so all this stuff is good, and then we can put a signal queue in the brain. Yeah. Alright, so now we can receive signals. But can we process them? No, we cannot. Not yet. We're probably going to want to have... So the thing is, like, there's this ballet that happens between the agent and the brain, where if the agent is already running an action, it will not call update activities. We may decide that that's not right. But that means we would need a new update method to handle signals and handlers and all that other stuff. And perhaps the brain should be managing the actions. There is no specialness in the agent. Like, here's a simple update in a test agent that I made for the test classes. If there's no actions, it runs the brain activities. Otherwise, it does this, and there's no reason this couldn't have been in the brain itself. And so I think I shall move it over there. Because then the brain can decide whether it wants to... Yeah, there's nothing specific about actions that require the agent, other than the initialize when we run them. And the brain knows the action. That simplifies the agent quite a bit. So yeah, let's move some of this stuff to the brain. So the brain will control... I was just thinking, would we have mobs that want to run actions with no brain? Is there value in having physics objects that can run actions? There probably is. But that being said, actions are agent specific. And an agent that would run actions would probably have a brain, at least a minimal one. And if we decide that we need shared code to manage, so this action queue thing here, then I could break that out into a separate, like, action runner class. So let's do this and steal. Yeah, so we're gonna take a yeah, this is gonna clean up a lot of other code at least. And yeah, the thing is, the action log is something we would lose here. Let me look at the real, the quote unquote real, the brain itself, the stuff that runs in the prototype, to make sure its update's not doing something that is. So instead of calling update actions and update activities, we could have just called brain update here. And update actions is doing all this stuff. It is clearing the steering. Which we could technically do from the brain. I don't think our agent has steering yet, but that's okay. Alright, I think I still have this stuff. Yep. Actions, current actions. Current action. Run action. We no longer want to do this on the brain. But let me see. Or on the agent. Oh, I got too far. I'm actually... I thought it was in the wrong package for a second. I got too much code open. Yeah, so we want to... steal that as well. Gosh, this doesn't feel like the right idea. I'm going to not do this right now because I want non-live stream brain to give that some thought before I go refactoring a bunch of stuff. I think I'm still good. Uh-oh. Signal queue. Oh, yeah. Signal queue no longer needs to be typed. See, all these times I had question marks. As soon as you start peppering these wildcards all over your code, it's a good sign that probably you didn't need typing anyway. Okay, so we've still got one that's hanging around on line 72. Yeah, there's one I missed. Anyway, I want to give more thought to the... And plus, we'll get... yeah, so we're not going to really... maybe we can at least receive a signal. I'm trying to think what I can get done before the live stream ends. So, yeah, so let's not do what I was doing and do... We don't have signal handlers yet. Let's really quickly see if we can borrow signal handlers. Oh, shoot. No. That's garbage. Composite signal handler was doing this. And I think that idea was probably okay. It's just the way it was doing it. Composite signal handler.java. And we'll probably use a built-in Java class for the interface, but we'll see. So what do we implement? What are we going to take? What do we have to call? So we passed the brain and the signal, and then we could just... Is there a by consumer? Yeah, Yeah, maybe just a by consumer. So for those who don't know a lot about Java or whatever, I'm looking in the wrong place. There's one of the functional interfaces called by consumer, which is basically a generic. Is there by consumer? Sure, there was. Yeah, I'm just not good at alphabetizing things. Yeah, so basically it'll just take an accept, and that makes it easier to wire things in. And so instead of so we'll take a brain and a signal as our thing, and then we will delegate that to other signal handlers. Yeah, so we want both Java util. We want Java util.function. We are going to, at minimum, have a list of signal handlers. And I think, yeah, this is... so there's no such thing as a signal handler. So these are all going to be additional by consumers. And that'll be the delegates. So what composite signal handler was doing was it was based on type. It could, and really this should probably be a map and or a multi-map. So then you could add these delegates. Yeah, probably want this. And then I can steal a bunch of this code for the infrastructure. Except for we won't have signal handler, although I could have made a sort of a mapping interface. But so everywhere, let's just do this. Let's say everywhere. Let's just say everywhere there's here. Replace with this. Oop. Boink, 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 boink. Okay. And then got that, we got that, we got that. So filtered signal handler is one we have to implement. And then we have to implement accept brain signal. And so then every one of these so that is one aspect of this, is that it used to be the first thing that handled the signal got to win. And so you could set up, and that's why I used a list here, because you can set up your signal handlers in a particular order, so some of them had priority. Let's not do that yet. Let's pretend that all of them get the let's pretend all of them get it, and so there's no preference. Delegates, that's good. All that's good, and I think I'm going to move this filter signal handler internal, because eventually I think I want to do this a different way. But let's go ahead and snag that one as well. We'll make it an inner class. Alright, so I'm going to at least see a signal handler put, like, if we can, well, it won't look any different because the brain dialog that we have has the sleep button, but the idea is put the sleep button on, or the work button, and it would initiate the activity that right now we're initiating with a different button. So it's not going to be like truly spectacular, but it'll prove that it's all wired up. Okay, we want to do this again. Place all them. Cancel. No. We want to signal handler T. Oh, I see. Yeah. Yeah, so that's what it was trying to do. We don't need this. We're going to make this protected and static. It didn't need to be. I'm just moving it in here so that it's private. Signals no longer a type containing thing. Signal class, signal delegate. That's good. This has got a bunch of type specific garbage in it. Boy, if I have to put that back, I'm going to be really upset. Okay, predicate can take the signal and decide what it wants to do. Yep. And we get the delegate, and so then this becomes @override, and I didn't add my @override up here, which is important to do, kids. That'll catch compile errors later, earlier than you otherwise would have. Brain. Our brain is braining. And so then we actually want to steal this stuff. If signal class, are we the same class we want? Otherwise, are we the same type? Otherwise, are we the thing? And actually, we just return, not return null. And then we return. We don't return anything. We just call accept. Yep. And then okay. See if we compile. Nope. First of all, that's not necessary. Wait, let's try to find... Oh, I see, yes. That's still true. What else was it complaining about? Invalid method, filter signal handler on line 111. Oh, filtered by consumer. This we can change back to signal handler. That's what everything else is going to be calling. Yes, okay. A couple of these I forgot. Let's see. Let's just do doink doink. Place. Okay, that's the last one of those. Handler. I probably could have just looked at the line number, but I wanted to check to see if handler, there we go. Alright, let's see what else we're missing. Well, first of all, implements, that's good. Accept. See, that was telling me more about my... Okay, yeah, we got it. Hooray! Okay. Now, let's see how the brain had that wired up. Over here, we just had this. Yeah, we won't get signal generators yet. I'm just kind of rushing through. And then the old brain, what did it do with these? We had on signal. On signal. We had a bunch of different on signals. We'll steal those. Okay. We don't need to do this anymore because we're not typed anymore. We shouldn't anyway. And this is no longer, so this is these are by consumers. brain signal. Skip, skip, skip to my loo. All right. See if that compiles. Nope. Oh yeah, we got this T crap. Boink, boink, boink. Replace all. Boink. Okay. Oh yeah, that one line generated 3 errors. That was fun. Incompatible class signal. On signal. Is that really necessary? Yes. And but it should be, in fact, it should be like extends signal. We won't have, in this case, we won't have specific signal classes anymore. We can just remove that functionality. So we'll just temporarily we'll stub it out, but we don't need this one anymore. We'll only have the one signal class, so you don't need to filter on that. Okay, and then this is no suitable method for add delegate. Yes. Yep, we just do that. Kind of an unnecessary method also. When we would have just used this. Yeah, so I'm going to get rid of that one and this one. We only need the one on signal. Unless we want to have one that listens to everything. Right. We may want, for debugging or otherwise, we may want one that just takes the handler. So I think that this will compile. We're getting closer. Yay! Okay. So we should have the infrastructure in place. Oh, we don't have an update thing to actually process them. So let's see where we call the things. Process signals. And so this would have generated the signals, process signals. Okay, yep. Brain. The brain is braining. Protected process signals. While signals is not empty. Poll signals. Generate reactions. Did a bunch of stuff that didn't need to be done. So yeah, we don't need to do that. Just signal handlers. Accept. Yep, okay. I have the signals handlers. Yep, so signal handlers. Accept signal, a brain. This signal. We don't need any of that. We don't need any of that. For now, we'll make this public. And doink to doink doink doink. Okay. Now we should be able to do some things. And hopefully in quick enough time that we can do it without bugs. It's funny, I look over at my screen over here and sometimes the frames are dropping. A little Max Headroom style. Oh. How many of you even know who Max Headroom is? It just occurred to me that that is probably a product of my generation. For those who don't know, Max Headroom was a spokesman for Coke? Was it Coke? Was it Matt Frewer? Is that his name? And it was like this weird like TV with a it looked computer generated, but it was just a guy wearing like a plastic suit with like fake hair, and then they like edited the video in such a way that it looked all choppy and stuff. But you may not know that there was a Max Headroom movie. Sort of they call it like 20 minutes into the future. The movie's actually good, and there was a TV series after, which was also pretty good, actually. I recommend it. A little prophetic in a way. The movie itself followed this reporter. Oh gosh, what was his name? And he was like a famous reporter, and like reporters went around with their own cameras and stuff, just like now, right? This was in the 80s, by the way. But you had reporters that would go around with like their own camera and stuff, and like investigate things, and like as long as they had their camera feed up, they were safe, because the other thing is like no one had power buttons on their TVs. You could not turn your TV off; it had to be on 24 hours a day. And so yeah, there was this reporter. He's like super famous, and he's like investigating these things called blipverts, which was like the Network 21 was trying to beam, like 5 minutes of commercials into 5 seconds, and people were exploding. And so he's investigating this, and then they end up like, I don't want to ruin the movie, but he ends up getting really injured, and they thought he was dead, and so they like copied his brain into this new that was Max Headroom, the TV box that he was in, to like replace him as the network, as the network personality, right? But then the real guy was still alive. Anyway, I recommend it. It was a pretty decent, weird and old, right? It's like 1980s, but very imaginative. And then the TV series itself was pretty good too. Weird sci-fi, but again, prophetic. If you look at it through a certain lens, it predicted the future pretty well. Okay, so now we want to change like this, sleep and work, instead of like right now, work will make us walk to the anvil. And we still wanted to do that, but we wanted to do it through signals instead. And so what I'll do is I'll first break these to prove that I'm doing what I'm saying I'm doing. So setup brain will call sleep test. Okay, good. I already mapped these through over to here. And so then for brain update actions. So before update actions, we want to process signals. Okay, so that should still compile. Brain process signals. Yep, okay, we're all good. Everybody's still good. She's still good. All right. And then we can set up let's set up the signals first. So let's go to the sleep test and work test. And instead of doing all of this stuff, all right, I'm going to need this code for the signal handler. Let me clean some of this stuff out because we don't need this anymore. All right. So for work test, we don't want to do this anymore. For sleep test, we don't want to do this anymore. We just want to call brain signal work. Okay. And over here, we want to call brain signal sleep. Okay. And so now I just approved that it's working. I've just broken these. They won't do anything anymore. They're just calling sleep test and do sleep, and work isn't doing anything anymore, right? They're sending signals, presumably. And so now what I'll do is I'll set up the signal handlers and brain on signal sleep. And we should be able to just do like this. Brain signal and work. So Groovy does have some nice aspects in these kind of cases. So sleep. So just proving that it's working. Handle. Actually, let's just say handle signal, and then we can see that they're really getting processed. So hopefully those signal handlers got hooked up. Brain sleep. Handle signal sleep. Dink, 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 dink. Handle signal work. Dink, 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 dink. Okay, so now, so normally this would be configured externally, right? Not part of the agent. So now I should be able to steal the activity code from work and test. So I'm just going to copy these so that I don't have to keep scrolling up and down. And so then we'll do this for work, which is down here. And we'll do this for sleep, which is up here. Get rid of these, we don't need them anymore. Those were just for reference. Okay, so we'll walk to the thing. Yeah, we need to look up bed, which we didn't do. Hopefully I didn't remove that part. Ah, there we go. That's the part I didn't copy. So we'll look up our bed. We'll go to 0.6 meters away from our bed. And then we'll look up the anvil. Okay, we'll go to 0.6 meters of our anvil. Okay, so this is like, again, this is sort of like the cheating way. What would really happen is we would probably instantiate a sleep activity that used this agent's properties to give the sleep activity some information about the agent, like, or it could just look it up when it's running. But the sleep activity would use like the agent's preferred home, his or her preferred bed, and so on and so forth, to then run a series of other activities. If the NPC, if the mob wasn't already home, it would try to go home, might get undressed, you know, put its weapons away, put its stuff away, and then get in the bed and sleep. And that'd be the activity that runs. And if something interrupts it, it'll try to make sure all those things are true again before going back to bed. So if something interrupts it that makes it put its clothes back on, and it runs outside for something, and then it wants to go back to bed, it knows it has to run through all those steps to go back to sleep. That's that kind of thing. So kind of like a state machine, kind of like a behavior tree, just a little more fluid. So anyway, let's see if it works. Now I've been jibber jabbering. Okay, so brain, go to sleep. Uh-oh. I think it's actually working. Yeah, iterate, iterate, iterate. There we go. Yeah. It's just there's a lot of logging now. So she's gonna go to sleep. She's gonna go to her bed. So the point is, it's working. Like it should have shown. Oh, let me unfollow so I can show It should have a path all the way up to the bed. Yep, so she'll get up there, and she won't actually make it to the bed, unfortunately, because like this is farther than 0.6 meters away. That's something we'll have to work on. Like, objects need to have defined areas, you know, like a chest, you want to stand in front of the chest. A bed, you want to be standing on either side of it, that kind of thing. In the nightstand, you want to stand in front of it. So objects need to have like some properties defined. Thanks. Yeah, so objects need to have some properties defined so that we can do more than just like try to navigate to their centers when we want to do something with them, right? They'll have, like a bed would have an enter positions. Uh-oh, where's she trying to go? Oh, she's trying to walk the actions again. She's trying to redo the action. Yeah. So the forked action didn't actually fail the task, the activity. So that's something I have to fix. So while I'm chatting, let me go ahead and see if the work one is working. Okay, so she's going to figure. She figures out how to get to work much faster than how to get to the bed. Anyway, so we'll follow her as she does this. But objects have to have location-specific properties. You know, the forge only makes sense to approach from a certain side. The anvil only makes sense to approach from certain positions, and some things will be even more specific than that. A chair has a front. Probably, unless it's a stool, these kind of things. And so to give the mobs a little easier time, objects will have to have these properties. Yeah, so activity kernel, update. Yeah, that's the one I said I should remove before we did this, but anyway. So yeah, the signals are working, the signal handlers are working. I hope to, like, over this next week or so, fix the pathfinding. I have an idea for how to do like rough pathfinding, you know, when there's no blocks at all. She should be able to just breeze through without having all these little steps, and then only have to drop down to the little steps when we get in and around other objects. So I have like an idea to explore that. What was that noise? I heard like a kaboom and a kawing. That's interesting. Not sure what those noises are. Anyway, so yeah, so that's what I'll be working on. Maybe next week we can start to work on sort of the prioritization of activities, like hooking sleep and work up to real things, and hopefully we'll have like better pathfinding between now and then. If my problems with pathfinding turn out to be interesting, we may do a live stream on that just so I can explain. But I really want to get to the point, like she does a lot of work to calculate this little detailed path. Let me unfollow. But really, like, through this area, she could have just breezed through with regular block queries. There was no reason to do all these little individual physics queries. And so I have a plan for how to deal with larger and smaller grids. And for large creatures, that's going to be important. You know, when a creature takes up more than a few blocks, that's going to be the grid they live in. They'll never be able to fit under things like this, right? In which case there was no reason for me to do little teeny queries like this. I could just step out in big queries. Anyway, all that's being worked. Hopefully by next time we'll have like a, you know, better, we'll be able to hook these up a little better and start building the real schedule. I may have to make like a little cafe here up on top of the thing, so she has a place to go to lunch and dinner, and we can start walking her through the cycles of her day that will be hooked up to the town, and so on and so forth. And because I'm building all this stuff out in the Java classes, hopefully it all meets somewhere in the middle, and we can actually put it in the game, which would be kind of cool. All right, I think that's where I'm going to end it. See if the thing's working. Yeah. All right, so thanks for watching. Consider liking, commenting, subscribing, etc. Join the Discord by downloading the game and hit the link. Anyway, that's all I got. Thanks, guys. Hope you have a productive week, and I'll see you next time.